Okay, so in order to add fractions, I need a common denominator. So I can make a common denominator of d by multiplying by this lovely fancy form of 1. D divided by d is 1. I can multiply by 1 without changing anything. And so now I'll have c over d plus 2d over d. And now that the denominators are the same, I'm free to add the numerators, c plus 2d all over d. And that is there, and we see our answer as A. Check. Okay, so similar idea in this one. I want to deal with the bottom first, so ignore the top and just subtract the bottom. So I can't subtract the bottom unless I have a common denominator, and I can make a common denominator of CD if I multiply this guy by C over C, so multiplying him by 1, not changing anything, and then multiplying this guy by D over D, multiplying him by 1, not changing anything. So now on the bottom, I have C over D minus, C over CD minus D over CD. And so the denominators are the same, so I'm free to subtract the numerators and leave the denominator the same. Note like if you had like 3/10 plus 4/10, that's 7/10, right? So the denominator stays the same. Don't do anything funky with that. And the top is just chilling while I'm doing all this. And then now, if we're dividing fractions, remember your elementary school teacher telling you don't ask why, just flip and multiply. So if I'm dividing by this fraction, I'm multiplying by the reciprocal. So if I'm dividing by c minus d over cd, I'm multiplying by cd over c minus d. And now we're quite happy because this c minus d on top is the same as that c minus d on the bottom. They cancel to make a fancy form of 1, and my final answer is just that CD. That is the only survivor. So we see that answer choice as C, and there you go. Okay, so I'm not allowed to add radicals unless I have like terms. So like if I had 2 square roots of 5 plus 7 square roots of 5, I would have 9 square roots of 5. But if I had like a root 5 plus root 7, that can't do anything. That would be as good as it gets. So you might think that this is as good as it gets, but I can simplify that root 27. Couple ways of thinking about it. If you can see a perfect square in there, if you recognize that square root of 27 is the same as the square root of 9 times the square root of 3, then you could say that this is 3 root 3 because the square root of 9 is 3. So if you see it's divisible by a perfect square, go ahead and do it. If you don't see that, or if it's a bigger number, you're welcome to factor tree it any way you want till you get down all the way to the primes. And since it's a square root, we're going to take out pairs of 2. One representative from the pair will come out, and anything that didn't get paired up stays inside. So no matter how you slice it, this root 27 becomes 3 root 3. So if I have 1 root of 3 plus 3 roots of 3, I have 4 roots of 3. And that is my answer, and I see it there as C. Check. So here we're trying to find a value of x and y that makes both of these equations true. So we have 2 equations and 2 unknowns. We can use either substitution or elimination. Here substitution works really well. Since the y equals this, I'm just going to replace the y there with what it equals. So I'm going to rewrite that first equation as 3x plus 2 times, and instead of saying y, I'm going to say x minus 1 equals 8. And this is better because this is just in one unknown, and I can just solve this without a problem. So 2x minus 2 equals 8. Combine like terms, add 2 to both sides, divide by 5, so x equals 2. That's all they asked for. We see our answer there is D, but they could have easily asked for what the y is as well. So just for fun, we'll say that y would be x, which we figured out was 2 minus 1, so y would be 1. So if you wanted a full ordered pair, the x was 2 and the y was 1. And you could check it in both equations, see if it works. So if I did 3 times, oh no. So if I did 3 times 2 plus 2 times 1, does that really equal 8? So 6 plus 2 is 8. Yep, works for the first guy, but it's got to work for the second guy as well. So the y we said was 1, the x we said was 2. Does 1 equal 2 minus 1? Heck yes it does. It's looking pretty good. Awesome. Okay, so they want the roots of this equation, which are basically the solutions of the equation, the value of x that'll make the equation true. We're going to use our zero product property to do it, and that's the idea that if something times something equals 0, then one of these factors must equal 0. There's no way to multiply to make 0 unless either one of those factors equals 0. So this problem will break down into two smaller problems that either the x minus 2 equals 0 or the 3x plus 4 equals 0. And then you just solve each one of those. So you add 2 to both sides, so x could be 2, or you subtract 4 from both sides and then divide by 3, so x could be negative 4/3. So your two solutions are 2 and negative 4/3, and they only listed one of the roots, just the negative 4/3, so they just listed the b. So that's our answer. You could check these by plugging them in. If you put in 2 for the x, 2 minus 2 times 3 times 2 plus 4, that's 0 times 10, which is indeed 0, right? And if you plugged in negative 4/3 in for the x, you would also get 0 because this factor would end up being 0. And that's that. So an equation of a line is y equals mx plus b, where the m is the slope and the b is the y-intercept. So if they're telling you that the slope is 3 and the y-intercept is negative 4, then you just plug and chug that in, y equals 3x minus 4 plus a minus 4, and that is all they want. So that looks like answer B. Check. All right, so I wrote all our properties of logs here. The only one we're going to be using in this equation is this first one. If I have the log of the sum, so I have log of x plus the log of y, I can smush that into a single log, the log of the product. So this left side I can make simpler by saying this is the log base 10 of x times y. And now I just use what logs are and write this in its exponential form to help me out. So log base 10 of xy means that 10 to the third power equals xy. So 10 to the third power equals xy, and they just happen to want to know what xy was, and 10 to the third is better known as 1,000. 10 times 10 times 10, and that's what they wanted. So it looks complicated, but it's not too bad. So lots of ways of attacking this one. You could say that you got 72 out of you don't know how many, and that's going to be 75%, which is 75 out of 100. So kind of the is over of equals percent over 100. 72 is some percent of x. And then you can solve this however you'd like, probably brainless just to do some loop-de-loops. So if you have an equation, you can do that the 75 times x equals 72 times 100. And then to solve for x, just divide both sides by 75 so that the x will equal 72 times 100 over 75. And you could just keep hacking away at this to simplify. I can divide the top and the bottom both by 25. So 75 divided by 25 is 3, 100 divided by 25 is 4, and then both the 72 and the 3 are divisible by 3. So 3 divided by 3 is 1, 72 divided by 3 is 24. So then the only survivors are 24 times 4 on the top, and 24 times 4 gives you 96. So there were 96 questions on the exam, and that seems fairly reasonable. Excellent.